In this video, I'm going to go over the Unit 5, Section 1 gas simulation assignment, show you where it is in our class folder, as well as go through the simulation itself and show you how it works. So to access this assignment, regardless of which CP chemistry class you're in, you'll want to scroll down to our Unit 5, Section 1 folder. And if you look past our initial Ed puzzle, you'll see that Unit 5, Section 1 simulation particles and gases assignment. You'll want to click on that and it will open a Cami doc that you can annotate your results in. I also have this link to the gas simulation, and this links to the simulation itself. So you might want to bring the assignment up on one screen or the half screen and the gas simulation on the other, or you can toggle back and forth between them as I will in this video. So first, let's take a look at the actual assignment posted here. This assignment should be pretty straightforward. If you read through it step by step, it tells you exactly what to do and also what not to do. And basically, it's broken down into 3 parts and a conclusion section. And in each part, what you'll do is you will change the simulation in a number of different ways. First, we'll change the number of particles. This will make more sense when I get into the simulation itself. But your goal is to record data that comes out of these changes and then graph that data on the right. And once you've graphed the data, we'll have these few conclusion questions afterwards. And I'll show you what I mean in the simulation. When you click on, heading back to our main folder, when you click on this link to the gas simulation to bring up the simulation itself, you'll see this screen. And what you'll want to do is click this big play button to actually start the simulation. Once it loads, you'll want to click on this ideal box because we're dealing with ideal gases. And now the way this simulation works is basically we're going to put gas particles into this box and see what happens to their pressure. And over the course of this simulation, you'll get a sense of what pressure actually is. So there are 2 ways to put particles in this box. The first is in the top right here. You can use this heavy particle toggle, and we're going to use heavy particles in this simulation. If you click this button with the 2 arrows, you'll basically see that there are 50 particles going in at a time into the box. So these are gas particles. You could also take this bike pump and drag it up and back down to pump in some particles. That might be more interesting, and it actually might help with one of the final conclusion questions. But honestly, I would just stick with this toggle up here. So I'll bring us back to 100 particles. So again, we want to take the data from this and put it back in our assignment itself. Notice that the pressure, once I put those particles in, is fluctuating anywhere between 10.9 and 11.7. What I would do is when it looks like that pressure is kind of reached its stable point, just hit this pause button in the bottom left. And whatever the pressure reads, that is the piece of data I would take. So for instance, when I have 100 heavy particles, I would take this pressure of 11.7 atmospheres, or ATM. So I'll take that data, I'll head back to my simulation assignment, and I'll type in 11.7 in that first pressure box. And I'll change this to red so it's easy to see that's what I am writing. Afterwards, I'll head over to my graph, again select red, and just put a dot at 100 particles on the x-axis and around 11.7. Ooh, that's not 11.7. 11.7 on the y-axis, the pressure. Eventually, you'll see more dots are going to be in this graph, and you'll want to draw a line that kind of goes through all those dots. And then from there, you can answer these conclusion questions relating to what is the relationship between the number of particles and the overall pressure, and then what would happen if you double the number of gas particles. You'll repeat this process for 2 other variables. First, you'll want to do temperature, which you'll see there are some first kind of instructions here telling you how to set up this part of the simulation. You head back to gas properties, set it up according to the instructions, and then you can change temperature by using this little bucket here at the bottom. If you drag up, you'll heat up the temperature, and if you drag it down, you'll cool down the particles. Notice that our temperature is displayed here in the top, where it says 219 K right now. That is Kelvin. That will be the temperature we use for this simulation. Again, we'll take data at various temperatures, according to the handout, about what that overall pressure is. And our last section of the assignment, is changing the volume of the box. You'll see these volumes, or the width of the box at least, listed here. Notice that if I click this width box in the simulation, it shows me the width of the box itself. What you'll eventually end up doing is dragging the box out to its maximum, 15.0 nanometers, and then slowly dragging it in a little bit at a time, 1 nanometer at a time, and seeing what happens to the pressure as you make that volume of the box smaller and smaller. The last thing I want to show on this simulation itself is that if you click in the bottom right here at this arrow, it resets the simulation to its starting point, which you'll have to do once or twice when you're going through the assignment. And finally, at the very end, there are 4 analysis questions. Do your best with these. Try to think about the scenario and what's happening and relate it back to the simulation. There are parts of the simulation that really help, but notice that some of these refers to things like balloons and tires. You may have to think outside of the box about what's happening in a balloon and a tire as opposed to this simulation. If you have any trouble, please send me any questions over Schoology, and good luck.